All right, so today is not a traditional note day. All right, if we were having school as normal, we would be doing an activity today that involves standard deviation. Now, even if you were in school and not at home, we can't do the activity the way we normally do because it involves groups and interaction and stuff like that that isn't going to fly this year. So I've modified the activity so that we can do it in school and you can do it from home. So normally I would break the class up into different groups, and we'd be taking measurements from each member of the group. But instead, I've just created some virtual groups. So these are our 4 people in group A and their various hair lengths in centimeters. And then on the back of this is our group B. Again, our 4 members and their various hair length in centimeters. So what you're going to do is you're going to choose either group A or group B. It's up to you. I don't care which one you pick. And you're going to calculate the standard deviation for that group from hand, by hand, not from hand, by hand. So this sheet will walk you through the steps. This table is for you to organize your work, but you're calculating the standard deviation by hand, and you're going to come up with a value for your group. You don't have to do both groups, just one group or the other. Then what I would like you to do is to speculate and take your best guess at these various questions. All right, so there's various questions that ask you to think about standard deviation and sort of hypothesize what you think the answers might be. The advice that I'll give you is when you're doing this, make sure that you're thinking of standard deviation as the average distance from the mean. All right, if you keep that concept in your head, it'll help you sort of work through it. All right, so you're going to go through, you're going to do all of this, and then you're going to come back to this video. All right, when you come back to the video, I'm going to run through the calculations by hand so that you can make sure that you got it right. And then I'm also going to kind of explain the correct answers to each of these. But you should try to do it on your own first, and then come back and check to see how you did on the video. All right, so I'm assuming that you've filled this all in and tried it on your own. All right, so now I'm just going to go through the work so that you can check your answers and make sure that you did it correctly. So I'm going to start with group A. So the first thing you would need to do is calculate the average of group A. So we've got 11 plus 58 plus 18 plus 26 divided by 4. And that should work out to be 28.25. All right. So that's your mean. So that's the value that you now have to subtract from each observation. So let me just use this table here. So these would be my x's, d8, 18, 26. And then from each of those, I'm going to subtract the mean. So I'm going to do 11 minus 28.25 and keep going one by one through these. All right, so 58 minus 28.25, get 29.75, 18 minus 28.25, and get negative 10.25, and then 26 minus 28.25, and getting negative 2.25. All right, so those should be your values. Now, we can't just average these together because if we did, the positives and negatives would cancel each other out. So we're going to go through and we're going to square each of those to get rid of the negatives. All right, so 17.25 squared is going to make that 297.5625. 29.75 squared is going to be 865, or sorry, 885.0625. The next one's just going to be 105.0625. And then the last one's going to be 5.0625. All right, so that got rid of all of our negatives, all right, by squaring them. Now we're going to add these together. All right, and when we do that, we should get 1292.75. All right, so that's the sum of all of those. Now we're going to divide by n minus 1, where n is your sample size. So for us, that's 4 minus 1, or we're just going to divide it by 3. That's going to give us 430.916 repeating. So I'm just going to add a couple of sixes here. And then the final step is to take the square root of that to get us our standard deviation, because we have to undo the squaring that we did here. All right. And when we take the square root of that, we should end up with 20.76, we'll say. All right. And again, it never hurts to sort of check this on your calculator. So if you go to stat edit, you type in the numbers. So I've already got them typed in there. Then you go to stat calc, one variable stats. You're going to see 20.758. Again, the rounding is going to be a little different just because we cut off some of the repeating sixes. But you are getting that same answer of 20.75 or 76 that we got. All right. So that would be if you did group A. All right. I'll also show you what you would get if you did group B. All right. So one second, let me get a sheet of paper. All right. So if you did group B, it would be the same sort of setup. All right. So again, it doesn't matter which group you picked. And if you want to skip this because you did group A, that's totally fine. And hopefully if you did group B, you skip the part where I went over group A. If not, you just get double the fun. So group B is 28 plus 64 plus 39 plus 48 divided by 4. That's going to give us our average. So x bar equals this, because again, this is telling us our average. All right, and that works out to 44.75. So we're going to see how far each observation is from this mean. So that means doing 28 minus 44.75, 64 minus 44.75, 39 minus 44.75, and 48 minus 44.75. All right, and this one would work out to be negative 16.75, 19.25, negative 5.75, and last but not least, 3.25. Now, again, we can't just average these together because then positives and negatives would cancel out. So now we're going to go and square each of these. All right. And the squares are what we're actually going to average together. Okay. So this one works out to be 280.5625. This one works out to be 370.5625. This one works out to be 33.0625. And the last one works out to be 10.5625. All right, so these are all of those values squared. And then we're going to add them all up. So they sum to 694.75. Right? Then we divide that by n minus 1. Again, n is 4. So this is 4 minus 1, which basically means we're dividing it by 3. All right, so 231.58 and then 3 repeating. But again, this is those values squared. So to get it back down to the original values, we're going to take the square root of that. And when we take the square root of that, we're going to end up with 15.22, we'll say. All right, that's rounding it a little bit, but it's good enough for our purposes. So this would be the standard deviation for group B. And again, never hurts to just type it into your calculator and verify that you got the correct answer, especially on this one. There's only like 4 values that you have to put in, so it's pretty quick. You can go to stat, calc, one variable stats, run it, and you're going to see that you get that same 15.22 that we just ended up with. All right, so again, whichever group you picked, hopefully you got that same answer. And then let's take a look at the back, because that's the part that's a little more interesting and makes you think a little bit about standard deviation, which again is a big part of our course. So it's important that we spend some time with it. All right, so what conclusion can you arrive at if the standard deviation for the hair length of an entire group is 0? So again, standard deviation is the average distance from the mean. So if your standard deviation is 0, that means that every member's hair length is equal to the mean. Now, the next question is, which group do you think has the smaller standard deviation? And then the second one after that is, which group do you think has the largest standard deviation and why? So we just did the calculations, all right? So group A had a standard deviation of 20.76. Group B had a standard deviation of 15.22. All right, so if we look at this, group A had the larger standard deviation. Group B had the smaller standard deviation. All right, so how could we have known that without actually doing the calculations? Well, again, if you remember, it's the average distance from the mean. So if we look at this, you could kind of roughly estimate that the mean is probably somewhere around like 40-ish. I mean, we did the calculation. It worked out to be 44 something. But you could gather that it's got to be somewhere in that 40 to 50 range and get a feel for like, all right, how far is this one from the mean? How far is this one from the mean? How far is this one from the mean? Or just another way, you could say like, all right, these 3 all have pretty long hair that's pretty similar. And yeah, hers is shorter, but it's not that much shorter. Versus if we go over here to the guys, we've got 3 guys that have relatively short hair. And then we have this one guy here with really long hair. So this one person is far above the mean for the group, all right? And since standard deviation is the average distance from the mean, his distance is going to be really large, and it's going to drag up that average, which means it's going to drag up the standard deviation. So as far as which group do you think has the smaller standard deviation, I would say group B, and this is even without doing the calculations, because all 4 members seem to have relatively similar hair. All right, obviously it's not the same, but relatively similar. Which group do I think is the largest? Well, again, we only have 2 groups, so I'm going to say group A. One member has hair significantly larger than the rest of the group. All right, and that distance is going to drag up the average because, again, standard deviation is the average distance from the mean. All right, so that average distance from the mean is going to get dragged up by that one member whose hair is significantly larger than the group's average. All right, so if a new girl was added to group B and her hair length is equal to the group's average, what impact will this have on the standard deviation? What about the mean? All right, so again, standard deviation is the average distance from the mean. I know I sound like a broken record, but if you add somebody that's hair length is exactly the mean, that means you're adding somebody that's zero distance from the mean. And if you add that zero distance to your calculation, it's going to drag the standard deviation down. All right, so the standard deviation will drop because the new member is zero distance from the mean. All right, and that zero is going to drag down the mean. Drag down the standard deviation calculation. All right, it gets tricky because like there's the mean, and then we keep saying average distance from the mean. So it can be difficult to keep those two separate, but they are two different things. Is zero distance from the mean, and then the mean will stay the same. If you add somebody that's exactly at the average, it's not going to shift the average up or down. It's just going to stay the same. All right. If everyone cut an inch off their hair, what would happen to the standard deviation for the groups? What about the mean? All right. So if everybody cut off an inch, we'd be taking the same amount away from every single person. So the standard deviation would stay the same. And the reason it's staying the same is because the distances to the mean have not shifted. All right, if you subtract an inch from everybody, that means your mean is going to also drop an inch. And if your mean is dropping an inch and everybody's hair is dropping an inch, the distance to the mean hasn't changed at all. And since the distance to the mean hasn't changed, the standard deviation is not going to change. And then the mean would drop by 1 inch. I'm not explaining the mean one as much because I think that's pretty intuitive. If you take an inch off everybody's hair, the mean or your average is going to drop by that same amount. All right, so the mean would drop by 1 inch. All right, if everyone ate a ton of bananas and their hair length doubled, because that's what happens when you eat a ton of bananas, what would happen to the standard deviation? What about the mean? All right, so I'll start with a quick one this time. All right, the mean would also double. All right, so if you take every observation and you double it, your mean or your average is going to be twice as big. Now, the standard deviation, and this might be the part that's not as intuitive, but the standard deviation will also double. And I think the easiest way to show this is with a quick example. So imagine that I have observations, we'll say 4, 4, 10, and 10. Okay. All right. So the mean of these observations would be 7. And every observation is 3 away from the mean. Now, if I were to double all those observations, I would then end up with 8, 8, 20, 20. All right. So I've just doubled everything. The new mean in this situation is going to be double the old mean. It's going to be 14. All right, so the new mean is 14. And if you don't believe me, 20 plus 20 is 40, 48, 56. 56 divided by 4 is 14. But look at the distance each observation is from the mean. Now, each observation is 6 away from the mean. All right. Contrast that to what we did with subtraction. All right. If we did the same thing with subtraction, 4, 4, 10, 10 would become 3, 3, 9, 9. The mean of 3 and 9 would be 6, and we'd still be 3 away from the mean. So adding or subtracting a number from every observation does not change the standard deviation. Multiplying every observation by a constant will affect the standard deviation. All right, so here we go from, again, this kind of illustrates mathematically that when you double, it does increase the distance that those observations are from the mean, which is going to, in turn, increase your standard deviation. And then, last but not least, in order for the standard deviation to remain the same, what type of hair length must be added to the group? Now, this is not exact, but I'm going to say the hair length would have to be one standard deviation above or below the mean. Because remember, standard deviation is the average distance from the mean. So if let's pretend my standard deviation is 10. If I add somebody that's 10 away from the mean in either direction, I'm just adding another 10 to my average of 10, which is going to keep the average constant. Now, this isn't totally exact because by adding this person, it would actually change your average, which would then change everybody's distance from the mean, which makes the calculation a little more complicated. But conceptually, this is sort of the idea. It would have to be one standard deviation above or below the mean because this wouldn't change the average distance from the mean. Because this wouldn't change the average distance from the mean. All right. So again, it's just sort of conceptually thinking about this in such a way that you can kind of grapple and understand why these various explanations sort of make sense. All right. So last but not least, we are reaching the end of the unit. So this is sort of the last day of material. At this point, all we've got left is sort of a review day and an exam. So this last sheet here is just sort of a useful reference sheet. There's not really any notes to take on it. It's more just for your own use. But it sort of breaks down how to describe a distribution using some of the different things that we've learned about over the last few classes. So the first thing you need to ask is, what's the shape of the distribution? Is it symmetric or skewed? And then which way is it skewed? How many modes are there? Is it unimodal, bimodal? And then where are they? Are there any gaps or anything unusual in the data? These are all things that you can say about the shape. And then based on the answer to those questions, you either go in one direction or the other. If it's symmetric, then you want to use the mean to describe the center because it takes all values into account. The spread, you can talk about the standard deviation. Again, it's the better one because it takes all data values into account. And ideally, there shouldn't be any outliers because outliers affect both of these. So you shouldn't have any outliers in a symmetric distribution. All right, on the other side, If it's skewed or they're outliers, you're going to use the median as your measure of center because it's resistant to outliers. For spread, you're going to use the IQR and the range because those are resistant to outliers. And then you should list any outliers or specify that there are no outliers and kind of give that detail. So this is just kind of like a useful flow chart to sort of organize your thoughts, because there will be questions where I ask you to describe distributions, and you have to recognize that based on the shape of the distribution, you're giving me different answers to these questions based on what's most relevant. All right. So again, this is just a summary sheet. You don't really have to do anything with it. I mean, the only word that I wrote on it here was range. We've got those two measures of spread. So other than that, I hope this is a useful tool for you. And that's all I've got for today. So have a great rest of your school day.